Section 6.3 is on factoring special forms. And our first special form is the difference of squares. So the difference of squares is we have two perfect squares and they're being subtracted. So they each need to be perfect squares, and it does need to be subtraction. It can't be addition. So what are squares or perfect squares? Well, if you take 1 times 1, you get 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And so on. So these numbers here would be perfect squares. And if we look at variables, so if you take x times x, you get x squared. X squared times x squared is x to the fourth. X cubed times x cubed is x to the sixth. X to the fourth times x to the fourth is x to the eighth. And x to the fifth times x to the fifth is x to the 10th. So basically any variable with an even power is a perfect square. So these are the types of numbers that we're looking for here. Now in the actual formula or the format, it's going to factor into two binomials. Both have a and b, and one of them is going to be subtraction and one of them is going to be addition. So I look at number 1 and I'm going to put two parentheses, one with subtraction, one with addition. Now in the first slots go a, and I'm looking at a squared and trying to get a. So looking at 9x squared, what times itself would get you 9x squared? Well, 3 times 3 gets you 9, and x times x gets you x squared. So 3x times 3x gives you 9x squared. So that's what I want to put here in these first slots. In the second two slots, I want to ask myself what times itself gives me 25, and that would be 5. And this would be our answer. If you wanted to check your work, you could. You can FOIL it. So let's check this by foiling. So I have 3x minus 5, 3x plus 5, and if I do all the multiplications, I get 9x squared plus 15x minus 15x minus 25. And you'll see the middle terms cancel out. So if you remember from the last chapter, we did have these two binomials where the middle terms cancel out. So now this formula, this difference of squares, this is really the reverse of what we were doing in the previous chapter. Okay, let's look at number 2. So I'm going to put two parentheses, one with a minus, one with a plus. And I need to ask myself what times itself gives me 64x squared. And that would be 8x. So it's kind of like you're taking the square root of it. 25y squared, what times itself gives me 25y squared? That would be 5y. So I want to put one copy there and one copy there. And that will be my answer. With number 3, I'm going to put my two parentheses, a minus and a plus. In my first two blanks, what times itself gives me x to the fourth, and that would be x squared. What times itself gives me y to the 10, that would be y to the fifth. So it's very much we are dividing the power by 2. And that's really because if you look back at the perfect squares, you're really just doubling the exponent. So 3 and 3 make 6, 4 and 4 make 8. So when you're trying to figure out what times itself gives you x to the 4th, you just divide the exponent by 2. So 4 divided by 2 is 2. 10 divided by 2 is those 5s. And that'll be our answer.